Hello student, welcome back to lecture series on correlation point, okay, which is from the statistic. I already started lecture series based on the M3 statistic unit 3rd. So if you're interested to see these videos guys, go and check in I button or you can check in my description box, okay. So in my today's video, I'm going to explain to you all the next sub point for the correlation coefficient for bivariate frequency distribution. Okay, so that means in simple language, if you have frequency distribution given, okay, if you have frequency distribution given, how can you handle correlation? Okay, yes, in my last video I explained to you all non-frequency distribution data sets. Okay, there we found the correlation coefficient, okay, covariance of xy, then sigma x sigma y, okay, and a method of a step deviation that we consider for whenever we have frequency table absent, only like a normal data calculations. Okay, so in our today's video guys, whenever we have frequency with our last point, then we take it as the bivariate frequency distribution. Okay, so see that regression between the two variable, it will remain same, it won't change anywhere. Okay, even if it is under frequency or even if it is non-frequency. Okay, yes, so regression coefficient like a covariance of xy divided by sigma x sigma y, okay, it will remain same. Okay, regression between correlation between x and y, okay, sorry, I said regression, it is only correlation. Okay, or of xy, it is a correlation between x and y. We write it as a covariance of xy divided by sigma x sigma y. Okay, now see that in my last point I explained covariance of xy with a normal data set. Now here I will explain covariance for the frequency distribution, okay, bivariate frequency distribution. So you need to have you need to know the formula for covariance of xy and sigma x sigma y. Okay, now see that there are multiple type of data sets. Some data set gives us the interval values like 0 to 10, 10 to 20. In such a case we have to apply different formula, or if you have a regular data set 10, 20, 30, so in such a case you have to apply another data set formula. Okay, so for that particular data set I'm going to write the formulas over here. Okay, so covariance of x and y, let me write covariance of x and y, covariance, okay, covariance of x and y for this numerator. I'm solving numerator right now. Okay, so it can be found by summation of fi xi yi. Okay, summation of fi xi yi divided by summation of fi. Okay, yes, minus x bar y bar. This is the covariance between two variable x and y. Okay, covariance between x and y, we write this way. Okay, yes, this is the covariance between x and y denoted here. Yes, now we can consider some another formula for this also. Okay, so if you want you can remember another one also. So we have one more formula, but the answer you will get the equivalent. Okay, you can apply whether this one or this one. Okay, it is completely based on the data set what you have given. Okay, summation of fi xi yi divided by n, summation of fi xi yi divided by capital N, minus we have summation of fi xi divided by n, summation of fi xi divided by n multiplied by summation of fi yi divided by n. Okay, this is the formula guys that you can apply this one for your finding covariance of x and y. Okay, it is very easier guys. Okay, not that difficult. So you can apply this one also or this one also, you will get the equivalent answer, but make sure that choose the appropriate formula as per the given data sets. Okay, yes, now I got the covariance of x and y here for our given correlation coefficient. Okay, now we want the sigma x and sigma y, that means standard deviation with respect to x and standard deviation with respect to y over here. Okay, so let me write standard deviation with respect to x. So you just need to know standard deviation with respect to x. Y you can write easily. Okay, yes, it is way easier to write. We take it is the under square root summation of fi xi square. Okay, summation of fi xi square divided by summation of fi. Okay, minus x bar. Okay, bracket square. This is a standard deviation sigma x, okay, that we needed over here. Okay, sigma x. Similarly we need sigma y. So if you want the sigma y, you can take under square root similar values, just only replace xi by yi. yi square divided by summation of fi, okay, and minus y bar square, okay. This one is a standard deviation, okay. This one is a standard deviation with respect to x and with respect to y over here, okay. Not the difficult, guys. It's very easier to remember these formulas, okay. So this value you have to find out for and covariance of xy just to replace over here, okay. Now see that whenever we have a higher number of calculation, we consider method for step deviation, okay. Let me take some formula for method of step deviation. There are 2 to 3 formulas. They are important over here, okay. Let me write for method of step deviation. See here, guys, okay. So I written here method of step deviation. In our step deviation, we introduce some another variable in the form of ui. So ui, which is equal to xi minus a divided by n. N, it is a number of attempts. A means the middlemost value in our xi table. Pi, which is equal to yi minus b divided by k. K is the number of attempt in yi, and b means middlemost value in the table of yi, okay. Yes. Now we want the covariance of uv. We write summation of fi, ui, and vi divided by summation of fi into u bar, v bar. U bar, it represents the arithmetic mean, okay, which is summation of fi, ui divided by summation of fi. And v bar, it is also denoted the arithmetic mean, the summation of fi, vi divided by summation of fi, okay. This represent u bar and v bar. Okay, now later on we want the sigma of u square and sigma of v square, okay, standard deviation of u and standard deviation of v. Now see that we are working on the correlation of r of xy, which is equal to coefficient of covariance of xy divided by sigma x sigma y, okay. So covariance of xy we can find using this formula, okay, and we want the denominator sigma x sigma y. So x and y we replace in the form of u and v, okay. So sigma of u square we write summation of fi ui bracket square divided by summation of fi minus u bar square, okay, and sigma of v bracket square we write summation of fi vi bracket square divided by summation of fi minus v bar bracket square, okay. Sigma of u square, sigma of v square, okay. These are the, we have two standard deviation, okay. Now that u bar represent arithmetic mean, you can see here. Arithmetic mean we know that already, summation of fi ui divided by capital N or summation of fi, okay, and v bar is the summation of fi vi divided by summation of fi, okay, or we write it as the capital N also. This is the complete method for step deviation, guys, okay. And we want one more correlation between x and y, okay. How can we apply correlation between x and y? That formula I'm going to write over here. Just you need to have an one feel about that formula. That's why I'm writing. It is quite bigger but not difficult, okay. Yes, it is quite bigger but not difficult. You just have to replace the value in our covariance of xy. We know that the covariance of x correlation between x and y, okay. How we write regression of xy? We write regression of xy. As we are taking u and v, so consider regression of u and v, okay. Regression of u and v, we write covariance of u and v divided by standard deviation x, standard deviation y, okay. That means standard deviation u, standard deviation v, okay. Covariance of u and v replace over here, standard deviation of u replace over here, standard deviation of v replace over here, okay. After replacement of the values, you just have to go for finding the square and square root, okay. So you will get the value. Here we all can see, guys, we replace all the values, okay, in our given correlation of xy, okay. Correlation of xy, it's similar like a correlation of uv, okay, because formula it is similar, just only the value variables are replaced here, okay. Yes. So correlation of xy or correlation of uv, it can be written as covariance of uv upon sigma u sigma v, standard deviation with respect to and standard deviation with respect to v, okay. After replacement of the value, you will get the capital E into summation of fi ui vi minus summation of fi ui into summation of fi vi. Standard deviation of u, you will get under square root n into capital E into n into summation of fi ui square minus summation of fi ui bracket square. And standard deviation of v, you will get the under square roots n into capital N into summation of fi vi square minus summation of fi vi bracket square, okay. This one is a complete correlation between the two variable. You can take as a xy or you can take as the form of uv, okay. Yes, that's it here guys, for the correlation. Okay, correlation for frequency, bivariate frequency distribution using step deviation. Okay, that one I explained. And earlier I explained correlation coefficient for bivariate frequency. Okay, for bivariate frequency, this one is very important formulas guys. Take it the note, prepare it. These are, we are going to use these example formulas for our upcoming example. Okay, see that if you want, take the note for this formula. See all this formula, then method of step deviation here. Okay, yes, that's it here. And at the end, I explained here all this step deviation result into the correlation between U and V. Okay, then at the end I figure it out, this formula. This one is important. Okay, yes, I hope you all have understood guys everything here in my today's lecture. It is way easier, not that difficult, but just need to remember the formulas. Okay, so that's it here for our today's lecture. In my next lecture guys, I'm gonna explain to you all some of the example based on the correlation. You will get the directly question guys in your question paper. Find out the or calculate Pearson coefficient for correlation. Okay, what you will get, you will might be you will get it, you will get the question in the form of xi yi table. Then you they'll ask you the question, find out the find out or calculate Pearson coefficient of a correlation. Okay, such questions are coming for 5 marks in your university question paper, so make sure that attempt this question. They are the very easier. Okay, but just need to remember the formula. Okay, so we continue some of the example in our next lecture guys. Okay, I hope you all have understood here in my today's lecture the concept which I explained. So even after, if you have anything difficulty doubt, let me know guys in my comment section. I will explain to you all this concept here in my lecture. Okay, so thank you everyone, thank you for my today's lecture.